So the project is already loaded, and we're off to the races. This is where we left off on Tuesday, okay? We had created a spawning box, right? And the code was in a class blueprint, or sorry, an actor blueprint to, it was like BP spawn something. When you can't select these things sometimes, you could say, go over to settings and say, well, it says it allows translucent selection. Sometimes it's hard to like select foliage because they have a lot of opacity, but that's why I have this little null right here. So the spawner, to recall from earlier, and this week's homework will be to spawn something using Max. So just a toggle to turn something on or off, right? We've changed the definition of what a tick is, right? From the main properties, we said the tick is every 1 second. If we make that a 0, it happens every frame. It's 90 frames a second. It's 120 frames per second. But I said, no, I want to use this tick as a counter. And this is going to hit every 1 second. And it's going to spawn an actor. And we chose from the actors the class of Good Jack, which was that pumpkin with the top and the bottom. And then where does it need to spawn? Right? It's asking, where are you going to spawn? What's the transform? A transform is a location, a rotation, and a scale. We don't need a scale, rotation don't care about, so we just grabbed a location, and that's the location of the center of the box, right? The location is right here, the null is, and then it's taking the location and finding the extents, the outer perimeters, and then we're just finding a random point in a bounding box. This is a little function that's built into blueprints. And then each time it pulls, so each time this tick pushes, it's pulling a location, right? So it's just saying which one, what location, and it's just feeding it random locations, just like we're doing random colors and random floats and random other things, right? Just pulling in those random things. And that's fun because, we got to run around and kind of dodge them, and I could definitely say, oh, every time I get hit, it could take a point away from me, right? It could bounce or... And the other interesting interesting feature added in was my form of rudimentary garbage collection, meaning I made them all destroy themselves after a few seconds, so we're not letting it get too chaotic, right? We're not letting too much weigh us down. I think that it would take a while for something this light, especially since we optimized it the week before, but that was all within, if you want to kind of follow the rabbit hole, that's all within this blueprint that we're calling. If I say browse, it takes me to that blueprint, and then we can recall that, oh yes, it's audio reactive, and that 2 seconds after it's spawned, after it begins play, that's the awake, it destroys itself. And just to prove, if we did this at 10 seconds, every single one of them would last for 10 seconds before it went away. Cool? And eventually disappear. And if you play a lot of video games, this stuff kind of happens. Whenever something blows up, if it's not a major asset, they'll usually disappear after a bit of time. And it's just to try to keep the performance going well. All right, so that's a good recap. And we definitely love the fact that the top is lighter than the base so that they fall at different rates. That's really fun. And then if I turn on max, it'll be audio reactive. But it's the same object. And what if I want everything to be audio reactive? Again, this one, what we've done is we made a, just to recap, I'm going to drill down into this material. We made an instance of our parent, just drilling down the rabbit hole. So this is the initial material. It has an initial color, which is yellow. And then I put a parameter. This is a scalar parameter. It's a single value. A vector parameter is like a color. That's 3 values, right? This is actually, right here, I can rename this into color, and we can change the color. In fact, let's do that first. Right, so we're already adjusting bright here, and that's going to emissive, so it can strobe, and it can have that blooming effect. Let's make it so we have a random color every time it comes down from the spawning. So I'm going to enable this parameter, which obviously, if I wanted to, while I look at the pumpkin, I could try to perfect it, right? and it can have some really cool looks to it, right? That's fun. And I could do this at runtime, and that's a way for me to dial in my settings, but that's just being a dynamic, or sorry, that's just being an instance, right? I want to make it dynamic. I want to be able to change it at runtime programmatically. So it's enabled. I can now attack it. Oh, but it's still called param. Let's save. I renamed it color, right? These are connected. If I hit save, you'll watch this number, this text will update. Now it's called color, right? That's just to show you that those two are connected. And that's why I'm going to be calling color from inside my blueprints. So we created a dynamic material instance for Jack for material index 0. Let's go back to Jack. And that is element 0. It has two materials. This is the static mesh editor. Material 0 is everything on the inside. And this is how you allocate it inside of Maya or whatever digital content creation package, right? And then the other UV mapping is on the outside.
So how do you get the mesh editor? I wasn't crazy trying to get it.
You just find the static mesh right here in this blueprint, and you just double click on it, and it opens up the static mesh editor. If this was a skeletal mesh, it would open up the skeletal mesh editor, which is also called Persona. Yeah, no problem. That's what you're supposed to. So we can isolate or highlight it, and you can imagine that when you have a really complicated asset, there'll be tons and tons and tons of these. And if I wanted to drive the outside of this pumpkin, I'm no longer attacking element index 0. I'm going for number 1, and so on and so forth. Each one has. This is how you count in arrays. You start from 0, 1, 2, 3, 4, and we'll get into arrays on Monday. Maybe today. Who cares? The other thing I'm doing is I'm saying what's my source material, just making sure that we're converting this material into a dynamic material instance, or I have a material instance dynamic. Those are the same thing. And so now we have something that can be driven at runtime, and then I have all this OSC stuff. And that's what's actually sending the values. I'm not going to worry about OSC right now. Let's just stay right here and do a random color. I'm going to steal this from my OSC because we're not using it right now. So we're going to do a few things when we spawn. Using control to move this around. The first thing I'm going to do is create it's converting a instance to a dynamic instance, so it can be changed through variables. But then what I want to do is set a random instance. Actually, I'm going to keep this down here. That's the brightness. That's fine. We can keep that on. We want to change the other parameter, which is called color. So bringing a reference to that same thing that we've created. If I control click, it means I'm getting it, or I can drag it and say get. I want to now, instead of, here's the question, if I have one value and I'm setting a scalar parameter, what is it when I set 3 parameters? That's called three scalars together, 3 floats that's a vector, right? That's a RGB or a XYZ. So I'm just going to, I know it's a vector, set vector parameter, and there it is. Find the right one. That is the right one. I didn't need to bring in the reference. And as we just established, this is an RGB and A. This is what's called a linear color. I want to expose that RGB and A, so I'm going to split it up. And then just like we did with the lights, I'm going to do a random float in a range of 1 to 0, because that's what colors are. They're from 0 to 1. and a unique one. Don't need you guys. You can do it here. Destroy, destroy after a time. And if I want to, I can clean this up a little bit and say, this is now a variable called destroy time. There's a default value of 10. But without further ado, let's make this thing change colors. With Alt selecting, I can, oh, what is it? Oh no, I think I just opened it up into Visual Studio. Okay, I'm gonna duplicate it. Too many node-based software packages. Cool, let's watch it spawn. So now every time it spawns, each instance is going to be its own unique random. That one's purple, that one's purple, that one's purple. So it's not doing it because I didn't give it a name. The parameter name is called color. Now, each time it spawns, we got a blue one, a white one, orange one, teal, purples, mauve, fuchsia, puce, you know. Great. So now you see we have random colors. But I want to have random colors for each one, but I want them all to be driven by the same audio parameter without having to, or I want all my assets for the rest of the project to all be running audio. So let's set that up real quick. Look at the guy, he's like, poof. Oh, I thought he was pushing the thing. Let's see if he hits it. Whoa. Well, I found a portal somewhere. All right. There we go. God mode. So here is a unique, or here's a new term, a new concept. Everything we've done before now has just been reviewing ideas we've already done before, but they're just kind of wordy, and so I want to say them again so that we just kind of brute force get used to the terms. What we're doing right now is we're creating a material parameter collection. And again, as we've talked about with game engines being lazy, we have to allocate resources for things, and we're going to create a collection. We're going to create one parameter, which for audio, that could be grabbed by every single thing inside the entire game engine. This is a really cool, powerful effect in that if you wanted every single thing to become saturated in your world, or everything to go fade to white, this is something you can throw into every single material, and you can reference it without having to say, it's this instance, it's this material ID, it's this, you have to would allocate, if we had 8 materials on an object, we have to make, if we had 8 material IDs, right? We have 2 right here. If we had 8 of these and we wanted each one to glow, we'd have to address it with 8 of these, each one allocating its own material index, and then each one creating its 8 dynamic instances. That's just tons and tons and tons of work. And you're going to find this is actually even simpler. It's almost too simple that it actually kind of, we'll go backwards and find out where it gets in the way. So this is something that's in your content browser. The second half of this semester is going to be so easy because we've done all the hard stuff the first half. All right. In my, I'll make this for everyone. This will be my assets, materials. I'm going to create a material parameter collection. And this is like a function library. This is an MPC, and this is Halloween. This is every single variable we want to be any material to pull in the entire project. And I'm just waiting for us to start adding them in. And I want to make one, which is called audio. Oops. I make audio, and I want it to be a default of 1 so that we can see the object by default. If it was 0, everything would be unlit. There we go. And now let's go back to our pumpkin. Boink. Boink. And we no longer need bright, which we could also have called audio or whatever. We're now going to grab a reference to that material parameter collection. Material collection. Exactly. Collection parameter. And we're going to see that no longer do we have to type in the letters. It knows which parameters we're looking for. We're looking for audio. It magically appeared, and we're going to put it in. Hit save. And by default, it looks exactly the same. Just to prove a point, if I'd save this default as 0, then the default setting inside of this would also be 0. And see how it's much darker now? So I want the parameter to by default be 1. 1 brightness means that's the default. And there we go. We can actually see it, right? It's white. Exactly. And ultimately, what we'll see from this is that nothing happens. It's exactly the same as it was before, but then we'll start propagating it through. All right, so we no longer need this. The scalar is now gone. And let's start driving it. I don't need this instance parameter again. Don't need this. I am going to set scalar parameter, and then if you see I hover over, it says material collection instance, and now it's a drop down. I'm picking Halloween, and I'm picking audio. I don't need to do any of the other things. I don't need to create a dynamic. It's just ready for me. But is it true? I said true right there, and then bring in the float, and let's prove that nothing has absolutely changed, that I just did a bunch of work for nothing. That would be ideal for me. I'll grab the last max patch. I uploaded one from last week, or from Tuesday, that had updates for 5B, 5A. It has its own app. It's called Mira, M-I-R-A, and it was also developed by an IDM student. Mm-hmm. So Max has its own iPad interface. Mira, let's do Cycling 74. And it's an iPad app. And basically what you do is you kind of throw in this Mira object, and then it mirrors the Max patch to your iPad.
Oh, so like they're connected.
Yeah, it connects. It basically makes a network between the two patches. But I'll show a more generic way that we don't even have to use Max at all. Again, Max is not necessary for this class. We're using it as a visual way of learning about parameters and like data types. But it's ultimately, if you're going to go into a store with your project, you would eliminate it as it's just a crutch that I like to use because I like to make sound effects. You know. So let's turn this on, and we're sending out data. Great. And to connect it on this side, we're sending jack audio. Okay. So jack audio is right here, and it's from 0 to 1 to 0 to 3. So it's pretty much what's coming out of here for brightness, which won't be too bright. We can always adjust it later. Let's go right now and see if it's working. So you can see that it's working, right? Great. Okay. So nothing's changed. that's the main important thing, is that nothing has changed, right? Because each of these objects would have had the other one. But now let's drive this material parameter collection and take it for a spin. So what is this guy wearing? You've got base blue. Okay, so let's go over to these over here. We have two instances. We had a base red and a base blue off of base color. take off emissive. And now remember, it's called a collection parameter. From the collection called Halloween, and we called it audio. We plug it in. And now these are audio reactive too, right? We're just throwing this around now. This is something that's available for everyone, right? So hey, and you get audio, and you get an audio, and you get an audio, right? We have all these Fresnels. These Fresnels are referencing a bass class, a Fresnel bass. You guessed it, they're now audio reactive as well. Collection parameter. So these are like universal global things. Now my Fresnels. Where are my Fresnels at? All right, here. Now Fresnels are also audio reactive, right? So this will be great. This is great. When would I not want to use this? If I used a collection parameter for these different inside colors, they would always be the same color together. Every time I spawned a new one, it would change all of them because it's a universal parameter. So certain small instances you want to keep close to. You want to keep close to the keep your deck close, because like if we make it universal, every time a new one spawns, it's going to event trigger out a new random parameter, and it's going to change all of them. Right? So there's a difference between why you would use an instance parameter and a global parameter. Audio being the main use case for a VJ set for doing something that's a global. And we'll continue to talk about this, but this is a major concept. It took a while for me to get it, like when you do one and when you do the other. But general lighting is great for doing universal stuff, but subtle things are great for doing the instance dynamic stuff. Cool. So that was the main thing there. I want to show you really quickly while we're in Max here this MIDI controller, and for the screen recording this will be good in just 1 second. So MIDI, I think it's a protocol made in like 80 or 81. It's old, right? And it's zero. It's has a lot of different channels. In fact, all MIDI values are, each one of these is a channel, and each one has a value. Right, so I have this one would be called channel 1, channel 2, channel 3, and each one has a value between 0 and 127. So this would be number 1, that's 1 to 127. So instead of being a URL or an internet parsed thing like OSC was, this is just a list of sending out some values. And then it also has, on some of these buttons, it also has intensity. Right? If you do it lightly, it knows. If you do it hard, it knows. Just like a piano, you would want it to every note to be the same velocity, right? And I'm going to show you something that's really cool with the newest version of Max. Is that just like Ableton, they have a MIDI mapping mode. So it used to have to do a lot of parsing, and now this is like dead simple. That's why I want to show you how much fun this is. So new, I'm going to hit S for a slider. I have to unlock it first. S for a slider. Here at the bottom. Let's do 2 real quick. This is the one where I hit Alt, make multiples, right? So I have a couple channels here, and I'm going to use these faders, the first 3 faders, right? Select the first one. Down here it says MIDI mapping. Select it. This is the one I'm going to MIDI map, and watch this. Are you doing it? Oh, plug it in. Come on, baby. This is old. It's been, there it goes. Automatic, just done, right? That's like super, super simple. Enable this one for mapping instead. There we go. Enable this one for mapping too. So anyone who's worked like a lighting board at like a theater, this is the kind of controls you're probably used to. And there we go. We have, oh, I think I mapped all of them to each other. Let's just do this one. And now I'll turn off MIDI mapping, and let's see. 1, 2, 3. So you can imagine how cool this is, just like adjust levels, really nudge it in, and like really make things kind of perfect. I think this is super cool just to know that these exist. Again, this is the Korg Nano Control, which has been around for a while. I'll just kind of put that in the Slack for you, just so you have it. And a week. Whoa, wake up. I'll put week 4. Alright, so you can go find those if you want it. Cool. And then, I mean, I don't really have to prove it to you when it comes to connecting the two, but let's go ahead and do it. Let's real quickly go to MPC Halloween, and let's add another parameter. And we're going to add a parameter for fader 1. Everything I want fader 1, or I'll do O1 in case there's multiple digits. So fader O1 with a default value of 0. Save it. And then we have to connect it to the OSC. All right, so this is what the values this is sending out. New print. It's going to be 0 to 127. That's what MIDI is. So at the very bottom it says 0 to 127. I can always just scale this to be whatever I want it to be. Scale 0 to 127 can be 0 to 10,000. New prepinned new channel, which is fader 01. New send UDP, so it goes to that UDP receive node that then sends it over to my IP address. I can also lock this and double click and say where is that receive, and it highlights it. It's right up here. That's where it's going to, and it's then being sent across. Then in any, let's open this up real quick. And we do an OSC receive for anything. So I'll make a template for you. VP global MIDI. Bring in that OSC receiver, which I still can't spell receive. Set an event for it. And then we put it on fader 01. So if we're on the channel fader 01, equals fader 01. Red is a boolean. We're doing a boolean check for our if statement. If it's on fader 1, branch is our if statement. We want to send that float value, pop a float, and then let's just print it out for right now. So here's a template for you. It's going to convert that to a string. And then there's numbers. So like you can see, like you can just start mapping all these buttons, all these knobs, everything real quick, and start really getting it going. To make this do something, let's just make a material quick and say here are MIDI null, get my collection from Halloween, and we did it on fader 01. Put it into emissive. It's blank by default because I made the value 0 by default. Now it'll be white by default. Let's just put a let's set our scalar parameter value, and again we can select from Halloween, it's fader 01, and we're getting that flip value from here. And honestly, it doesn't have to be in this blueprint. It could be any object that's connected to that parameter will now be driven as long as this blueprint is in the world. A little Midi. So we can literally map the entire thing to this blueprint, and as long as it's in the level, those values will be sent out and will be collected by every single object inside of that level. I can, to prove that they're connected, go to my level blueprint. Where's my tick? I'll just find it. Event tick. And so every frame, I just want to get parameter. Let's see, get global, get scalar parameter value for audio for fader 1, and I'll print it here instead, just showing that everywhere, anywhere can grab this value. And then I'll have to rest my case. Alright, so this is coming from my level blueprint now. Right here. There you go, so that's a global value. Cool. So we have one hell of a playground here. Alright, this has been a little bit of a mess. What we're going to do is we're going to start a new one for our final project, and then when I upload it, you guys can take a look at, this one will be more streamlined without all the mess, so that it's just things we're using. So we're going to do a new level, and I'm going to create a blank one. Straight empty. And to make it a little easier on myself, I'm going to add in that sky sphere. So I can see while I'm working. It's like a work light. And then what I'm going to say is whenever I hit play, go ahead and be hidden. So now my actual project is still dark, right? But I have that light to work in so I can see things I'm doing. We're going to go to 0, 0, 0 and add a target point. This is a nothing, it's just something you can reference. It's at 0, 0, 0. I double click on it to find it. There it is. And now our project is going to be mainly, because we're going to be doing a lot of spawning, it's going to be mainly in our level blueprint. Grab a reference to it, and then we can get the world transform or location. I don't know what the transform is. Yeah, that's fine. We'll do the world transform. And then, as you remember, we have spawning an actor from class. Could be on key presses or toggles and buttons and all that kind of stuff, as you can imagine. We'll put that together in a little bit. For right now, we'll just do input O, the letter O, and then we'll do the same for, actually what I'll do is on event begin play, I will promote this to a variable called center of the universe. And then I don't have to worry about repeating that over and over again. And now I can just drag them into there. And we're going to do two things. On O, we will spawn a skeletal mesh, and on P, we'll spawn a static mesh. And that's going to be the basis of our VJ set, was that we're going to spawn an actor, have them do dances, blend between dances, have them rotate around, have them go in slow motion, have them go away. Spawn a static mesh, have it be audio reactive, spin it, distort it, have it go away. Spawn some lights, rotate them, change the color, make it go away. Spawn all three, make them go away. And that's the basis of the entire set. Right? And that's what we'll be building in 2 weeks. Right? So we have a lot, well, it needs the class, obviously. We have a lot of assets, like we have a lot of things that you guys have uploaded, that I've uploaded for you, things I've uploaded, but everything's kind of of different scales, and everything's of different kind of, they need some finesse. Things need to be centered and raised above the ground. And what we'll have to do for all these things, instead of spawning just the meshes, we'll have to make each one a blueprint so it's perfect, and just spawn each of those blueprints. Right? So that's a way for you to like fix any offset pivot points and all that kind of stuff. So here's your blueprints. I'm going to call one BP skeletal. I said skeleta. That's something different. And let's bring in a skeletal mesh. Doesn't matter which one for me. I'll choose one of the ones I worked with. Oh, so many good ones. I'll bring in my male mesh. And my female mesh. Alright, so here's male mesh. And we'll give them a default animation. Not using animation blueprint, using an asset. Oh, do I not have an asset for him? Yeah, I don't have an asset for him. We'll use another one real quick then. Female. What about Hat Guy McGee? No. What about... What's the other one I did? Doesn't really matter for right now. We'll use the Titan that's right here. Titan has a zombie walk. Looping, playing. Here we go. Save. I wonder why it's not going. Are you in real time? You're in real time. Let's find our animations in our project and do it from that way. Animation asset. Animation sequence. We can do... Okay, female root had some, so we'll use female root. Let's do that. Female base mesh root. So many. And we'll keep it with run. Nothing's working. We'll try it anyway. Let's clean up some of this mess. And we'll save all. And this project will be now in our assets maps, and this will be called performance map. I saved all. Winding up. So my BP skeletal will be on O. BP skeletal, I can type it in. And then that one's now compiling. And then we'll make one more for BP mesh or BP static. And in this one, I can look for a static mesh. It could be any of these things. Let's find all our static meshes, filter it, static meshes, and the root. I'm still enjoying Slender Man. Let's go for that one. So Slender Man. And as we noticed before, it was like big, right? So because we have a blueprint, we can go ahead and make it the way we want it so that it fits perfectly into our level. All right, so we don't have to worry about adjusting it with our parameters. We could do it here so it's perfect, right? We might want to bring it down, back, and now it's perfect the way we want it. BP, there we go, they're going to be the same size. And let's put in our static mesh. Compile, and we have no errors anymore. So we're going to be able to spawn them. And the last thing we're going to do in Unreal today is then learn how to destroy them as well. So let's put in one light. Just see what we're doing. Like a spotlight. And let's make it creepy. Alright, it's theme. 0, 0, 0. 0. Double click on it so we can see it. And then let's make it look up. You know, that creepy underlighting kind of thing. I think that looks up. Yeah. There we go. And let's give it a little orange. We can always change this later on in Max or whatever.
Can I ask a question about
Yeah.
the dome light? Like, it's a dome light, and the unit is like different. It's not.
It's CD Candelas.
No, it's like another.
Oh, you mean the sky sphere?
Yeah.
The skylight.
Forget the name. Yeah.
Yeah, skylights
The
are probably in
skylight.
lumens or something.
Yeah. Because I didn't find that unit, like, it could not be controlled by the Max because it needs like to be converted into that unit.
Yeah, I mean, skylights are usually things you bake in there, but we can. I'll take a look at it maybe when we break out into working on stuff, and we'll take a look at it. I don't have a shirt on him. I can always add an audio reactive shirt, right? Let's find out which one is his jacket, right? So we'll highlight. That's that. That's that. Let's use a Fresnel. Inst. And that's that. So we have obviously we could bring in some other things there to dress them up and make them perfect. And let's go ahead and spawn them. Hit play. I'm going to bring in O. We'll spawn. Let's do a wireframe. I spawned that guy. That's hilarious. 1 second. Let us go to our world settings and make sure that it doesn't think that we're playing a third-person game. Set it to game mode. More time. Oh. Wireframe. Let's make sure that they're connected. Oh, I never actually put a camera anywhere. That's what's funny. Right? I was looking, who knows where I was looking. Let's go back to here. There's our 0, 0, 0. And you can actually just kind of look at something and say, place a camera right here. And now there's a camera right there. Let's straighten it out. Zero, 0, 0. And then bring it back. Negative 180. And let's take this light, move down. Let's try again. I can see it. Can you see it? There we go. So we're still figuring it all out. The camera needs to be player 0, which is down there. Let's try it again. There we go. So we could definitely get it closer. And maybe it's the scale of the object as well. There we go. All right. Cool, right? We had one more we were going to do. Alt-P as you play. And let's do the other one, P. Where's my Slender Man? For debugging, let's not get too much into performance mode. Let's not make it hidden. Let's make it easy on ourselves. And see where Slender Man's right there. Okay, great. Bunch of them, bunch of them. So I'm going to take this and move it out this way and rotate it. So something like that. 0, negative 400. Positive 400 is what I meant then. 400. And then 0 it out to negative 90. And now we're ready for our show. We can 0, 0, 0, P, 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 P. Great. So now you can see it's just a matter of refining that, getting it closer, and then also potentially making the assets more uniform. A skeletal maybe could be a little bigger. And then everything just kind of has to be perfect like that. Making sure it's framed. It seems to be the same scale. And then the last thing we need to do is what happens when we want it to go away. When you're working with functions, functions often return something. We've already done that before with dynamic instances. In the same way, we're going to create, because these things don't exist in the world already, we can't reference them here. We're going to be spawning them on the fly. So let's give it a name, and we can actually find it inside that world outliner. So this one's going to be called our spawned skeletal. I did that thing where I have cap locks on. Spawn skeletal. And then the same way we'll be able to reference our spawned static. And then when I want to release the button now, we're going to then destroy the actor. In the same way, you don't have to do it that way, we can just do it this way. Spawn skeletal, spawn static, and when I release, it goes away. When I release, it goes away. Let's bring the sucker up, bring it closer, and now I hit play. It's there, let go. And this is more like the momentary, right? That we're talking about between a toggle where you turn it on and you let it go. Now we have right? So now we're creating a little play, something we can play around with. So I'll write it out more in long form when we break. I haven't really written the assignment, but the idea is just to spawn a skeletal mesh, spawn a static mesh. If you can do it from Max with OSC, that's probably smarter. If you have one of these, try it out. We have some of the equipment room to try out. Each one's a little bit different. Some of them are funky, some of them are real old. The newer ones don't need to be plugged into power. They just get powered over USB. That's obviously the way to go. And then I'll write out more long form, and the idea is, screen record either with your phone, whatever. Just put a video on your blog post, put a link into week 5, and then we'll review them on Tuesday, right? And then next week we're going to get into projection, and we'll get into sending these video frames back and forth. I don't really want to go into Max right now because I feel like that's just too much. I've already demoed for over an hour, and that's plenty. So let's just kind of work around on what we have right now. Get ahead of your homework. Get it done today so you don't have to do it over the weekend. And I'm here to help you make sure you can do it. I'll save this and I'll upload it so you can pull it if you're referencing the projects in class, okay? Do you have any questions about what we did here? We went over a lot when it came to the different parameters, like the dynamic instance parameter versus a global parameter. That will just sink in over time, but it's really, really useful to get used to that because that's kind of like the amount of, that is the crux of interactivity when it comes to these game engines, is change these things in those two different main ways. Everything else is just details. Cool? So if you need, feel free to take a break right now and go to the bathroom. Use the non-existent cafe and drink machine and all those things.